Hi friends, a very good evening and thank you for joining in. Could you just confirm if everything is working as expected on the YouTube live itself so that we can get started with today's session? Let me also just check it on my phone to make sure everything is okay. Everything looks all right even on my phone, so good. Yeah, everything looks all right, so no glitches. Good. Okay, we will get started in another 5-6 minutes at 7:02, 7:03. So in the meantime, if you have some questions, so this is the last major subject, of course, if you count. So we are left with two subjects in the first iteration, COA, which is Computer Organization Architecture that we're starting now. This will take us about 2 to 2.5 weeks to finish. And then we'll have only aptitude left, right? So with that, we'll finish the first iteration of all the subjects. Cool. COA, it's one of my favorite topics personally because I really used to enjoy computer organization. I always wanted to understand how a computer works internally. And COA and microprocessors were two subjects which help you understand the nitty-gritty details of things. Cool. Yeah, any questions you have, I'm happy to answer, take a couple of them now. As usual, at the end of the session, I'll answer more questions. So Shavik, in the second iteration, we will also be doing some public live sessions like these, but we'll have, of course, more sessions for the course enrolled students. But we'll be doing some of these general sessions. So this is Linga who says, how many marks should a general candidate get to get into one of the PSUs? Again, PSU admission is a little tricky because some PSUs have positions open in some years and the number of positions is not always fixed. But roughly speaking, at least from our limited experience of PSUs, because for computer science students, the number of PSUs are fewer. And again, the number of seats in each PSU is also typically smaller than, let's say, electrical engineering students or mechanical engineering students, etc. So typically, if you're in the top 200, 300 ranks, there's a very good chance that you will get into the few PSUs because in general, most CS students are not very inclined for PSUs in general, right? So this is Lakshmi Narayan who says, I'm aspiring for GATE 2023. Okay, not this year, not in the next 4 or 5 months, in roughly a year and a half. I completed CN, TOC, CD, DLD. Which subject should I choose next? So Lakshmi Narayan, since you have a lot of time because you're preparing for GATE 2023, you're a year and a half away from it. So just go to our website, which is gate.appliedroots.com. We have a blog where we describe what is the order of subjects that you can cover. This order has been thought through very carefully, keeping in mind the marks that you can obtain and how easy is it to obtain. That's one strategy that you can employ. Again, there is never one right strategy. Another alternative that I would suggest you is pick up the subject that you're most frightened about because you have time on your side, right? So pick up the subject that you're most frightened about and finish it first. That way, the easier subjects will be left at the end and you'll be less stressful throughout the as soon as you complete the hardest subject for yourself, the rest of the subjects will be easier for you. That's one strategy that you can surely think of. So this is a student who says, I'm from VIT Chennai. I'm a second year CSC student. Should I prepare for GATE? If yes, then when should I prepare? Again, if your objective is to get into one of the top universities to pursue your masters, then GATE is the right choice. Otherwise, it's not. It's as simple as that. Ask yourself this question if you want to pursue a master's degree and some specialization. Having said this, we typically recommend students to prepare for, if you're thinking of GATE seriously, please use your first and second year to build your programming skills. Become good at programming, data structures, algorithms, maybe some subjects like databases, etc. So first year and a half to 2 years, you can focus on it. Third year is a more appropriate time to start your preparation for GATE. Again, most students do it. There are exceptions to this rule, but this is a typical unwritten rule that most folks follow. Cool. So I'll take a couple of questions again, and then we'll go into the problem solving itself. So the general aptitude itself, there are some topics that I have taught, but we have better faculty members who teach aptitude for various competitive exams, and we felt they are better equipped to teach than me, because I have not taught aptitude per se. Of course, I can teach, but there are better people who can teach it much better than I can. So we always try to find the best instructor. For example, I may not be the best instructor for English, because apart from learning English in a typical setup, I'm no expert in English, right? In a typical school setup, I've not learned anything beyond that. So somebody who has taught English, or somebody who has taught actual problem solving ability to various types of competitive exams, we felt those people are better equipped to teach than me. Okay. Okay, so let's get into the live session itself. Let's solve the problems. We'll come back to the general Q&A in a while. Okay. So let me start sharing the screen. Let me also check if the screen is visible in the live. Again, I'll take some of the questions here. I'll take some of the questions at the end as usual, right? So let's just focus on Q&A. Okay, the screen is visible, no glitches. Is everything all right? Just wanted to make sure before we start solving the problems. So one small note I wanted to mention, a lot of computer science students think that computer organization architecture is something that I would never use. Please understand that this is a very, very foundational subject. This is a subject that I am using, concepts that I've learned in my undergraduate studies. I'm still using them like 12, 13 years, almost 15 years after my undergraduate education now. And that's because as somebody who works on machine learning, right, we have to always think about how do you run your code very, very optimally on a computer organization that you have, right? I could be running my code on a mobile phone, which most mobile phones have ARM architecture, which is like a RISC-based architecture, right? Or I could be running them on an advanced Xeon processor, or I could be running some of my machine learning code on a GPU. So again, speed, if you want to run code fast, if you want to train machine learning models, all of it, having a solid undergraduate level understanding of computer organization will help you immensely become a better machine learning engineer. Like I was reading some research papers and some articles very recently, and it was all about how Xeon processors, the Intel Xeon processors, the high-end server processors have optimized to execute machine learning much more efficiently using lots of computer organization specific hacks. Like for example, they've created a completely dedicated instruction set for machine learning operations. They've also created different types of floating point representations, which can, especially for high-end Xeon processors. Like I wouldn't be able to understand this work without having a solid undergraduate level understanding of computer organization and architecture. So those of you who think, hey, this is a subject that is not very important for me, please double think it, because if you want to get into careers in machine learning, having a solid understanding of computer organization will help you in the long run. Even if you want to become a good software developer, you often have to write low latency, high throughput, distributed computing stuff. And having a good understanding of computer architecture or computer organization helps you immensely, even in distributed systems. So please don't look at this subject as something that you're just preparing only for GATE, right? Just wanted to give you that basic intro on the applied aspects of COA. So let's get into today's session, right? Let's start solving problems. Today's session will be one of the easier ones because we're just getting started with the initial concepts in COA. Most of the questions in today's session will be on the easier side because the concepts are also simpler. Simple addressing modes, basic CPU instructions and things like that. Again, please post your answers in the chat window. As soon as a good number of students answer, I will explain the solution. This is a typical 1-mark type of question. Again, since this is an MCQ, you can easily eliminate options. Most of you got it right. A few of you, I think, probably are a little confused with the addressing modes, but most of you have got it right. Okay, so let's solve it since most of you have put in your answers. So if you observe these, right, if you see these 4 options, just look at the options and let's eliminate. These both have E as the first option, these both have B. So what is the first one that we have? The first one that we have is register indirect, right? In register indirect addressing, what will be your effective address? So whatever is there in this register RI, this will give us the address, the memory address from which we have to fetch the operands typically, right? So RI, so the effective address will be whatever is stored in the memory location whose address is in register RI. So 1 will match to B. So the moment you know 1 will match to B, you can eliminate A and B. It will either be C or D, right? So if you see the second option here, the second option, there is not much of a difference. Both of them are mapping to E, right? So register addressing, yes. So whatever is the value, that becomes your effective address. Very simple. Next, the third thing that you have here is, okay, where do they differ? Okay, they differ here. Even in the fifth option, they are not differing. Only 3 and 4, they are differing. What is 3? 3 is basically indexed. So which of these is, so it's a choice between C and D, right? So remember, you have indexed and relative addressing. So in indexed, what happens here for you is, this is again, for 3, the right option will be D. Okay, let me just erase this. Okay, so for 3, the right option will be D. This is relative addressing. Again, in relative addressing, what we're doing here is we are saying whatever is there in the program counter, we are going to add some X to it, right? We're going to say, hey, whatever is there in the program counter, relative to that, go these many steps, and then this will become my effective address. In the indexed, look at this, in the indexed mode, whatever is there, so I'm using my register RI as basically the index register here. Right, so whatever, so RI now becomes an index register. To that, I will add some X, and that becomes, and the memory location that's stored here becomes my effective address. So if you see this, 3 has to map to D, 4 has to map to C, 5 anyway. So the right option here is D. Right, most of you got the same thing. Again, this might be a little tricky, little confusing. So that's why the best way to tackle this is, again, you can eliminate A and B very easily, but between C and D, it is all a choice between indexed and relative, right? So you just have to see it carefully, and relative is relative to the program counter. Indexed is basically your offset. In indexed mode, this will be your offset. Your base address is whatever there is there in the index register. That's it, right? Very simple. Again, here X is like an array indexing, right? It's here X is basically going to be, okay, like something like 10, right? That's what is implicitly understood from this. Okay, cool. This is an easy question, very easy question. That's why I said 1 mark question. This is just about, do you understand various modes of addressing? That's it. Okay, here is the next question. Again, please don't panic seeing slightly lengthier questions, especially in COA. Read it carefully. They tend to be easy. So they tend to be easy, you just have to be slightly careful. Again, a very important suggestion I would make here is, please draw diagrams. Please draw diagrams. In COA, this will help you understand what's happening and solve with much more accuracy. This is true for many subjects, but specifically for COA. This is also a typical 1 mark type of question. Sometimes could even be for 2 marks. Sometimes. Again, please read all the information given in the question carefully, draw diagrams and then solve it. Don't be in a hurry. Again, please revisit your answers. Please cross-check your answers, folks. I think some of you have made silly mistakes. But again, just cross-check. Anyway, we will solve it together. Probably I have made a mistake. That could also be the case, right? Again, this is a very simple question about instruction set design. Somebody saying E is the answer. Boss, what is E? You're saying none of the above? Gautam, since you have mentioned about the notes, the objective of the notes is to revise. Otherwise, it would become like a textbook if you go into every nitty-gritty detail, right? It's the primary objective of any notes that we share is to revise, not as a textbook. Please understand that. And if there is anything specific where you see something is lacking immensely, do let us know and we will work on it. That's not a problem. But please use the notes for revision, not as a standard textbook, because it's not meant to be used as a standard textbook. Okay, cool. So let's go into this. So it says, right, that, okay, let's start reading it, right? A computer has a 24-bit word length, okay? One word is 24 bits and all the instructions are one word in length. So each instruction is 24-bit. Cool. Every instruction has 2-bit fields, right? So which specifies the instruction type, right? So instruction type now is, okay, let's start filling it up. Instruction type is 2 bits, okay? The number of registers in the architecture of the computer is 26, okay? 26 registers. Now to address 26 registers, you would need 5 bits, right? Because with 4 bits, you can only address 16 registers. With 5 bits, you can address up to 32 registers, right? So to address 26 registers, you need 5 bits. Simple fact. Okay, next. For a format with 2 register fields, okay? So you need an opcode first, You need an opcode. Then you need 2 registers. Let's call it register 1 and register 2 because it says that you need 2 register fields. One immediate field or an address field, okay? So there is also an immediate field or an address field. Okay, fine. And a maximum of 64 opcodes. This is good. So because there are a maximum of 64 opcodes, you need 6 bits for this. So 6 bits go away for this. Now registers, 5 bits each. So 5 bits will go here, 5 bits will go here. This total width is 24 bits. We know this. That's why I said just draw diagrams. It's as simple as that. Now what is the question? What is the maximum number of bits available for the immediate field or the address field? Very simple, right? So what is the sum of these? This is 8. 8 plus 10, 18. 24 minus 18 is 6. It is not 8. I think some of you made that mistake. 24 minus 18, right? 24 minus 18 is 6. It's not 8. Right? I think that could be a possible mistake why somebody got, I think, D as the answer. Okay, so that's one field. And the largest unsigned integers for the immediate operand. Suppose if you have 6 bits, right? What is the largest unsigned integer? So if you're doing an unsigned integer, right? So you have 6 bits. What is the largest number? All ones. And all ones will correspond to 63, right? Because 1 followed by 6 zeros is 64. So 1 less than this is 63. So the answer is 6 and 63. Now I'm really curious, those of you who have marked D as the answer, why do you think D is the answer? Some of you said D is the answer, right? Why? No, it's clearly given here, right? That there are two bit fields which specifies the instruction type. It's clearly given, right? And it says that there are number of registers, there are 64 maximum opcodes. It's straightforward. Oh, some of you missed the 2 bits. Okay, good. So this is a silly mistake, right? Probably you didn't read the question carefully. Good. Okay, silly mistakes. See, this is very, very important. When you have lengthy questions, please read the question very, very carefully. So it's just going to be like, you will make crazy silly mistakes if you're not careful. Okay, please read everything. My recommendation, this is how I tackle such problems. I draw the diagram. While drawing it, I read through each of it, right? Because I know what is being expected, right? So try and fill all the information that's here, see if it is relevant and fill in all the details. Otherwise, you will make silly mistakes. I was very surprised when so many students said D is the answer. I thought probably I have made a mistake somewhere. Okay, so just be careful there. Cool. Okay, so this is the third question. Also about addressing types or addressing modes. Okay, let's solve the third question. This is like a 2-mark question, primarily because there are multiple addressing modes that you need to know and apply to solve this problem. Again, the basic addressing modes and simple instruction set type of concepts in COA are the easier ones. That's why I said there will be easier questions from this topic. Again, just look at the diagram carefully, read the question carefully. Fairly straightforward question. Good. I see many of you getting it right. Okay, I'll wait for a few more seconds. Okay, cool. Let's solve this, right? So it just says load 2000, right? And the question says that the index register R1, so R1 contains 400, and this is some of the addresses in the memory. So it says if you're using these 4 types of addressing modes, what will be the actual value loaded into the accumulator? Okay, not the address itself. It's asking what is the value loaded into the accumulator. Okay, so in the immediate addressing, right? So let's start this, right? So in the immediate addressing, what happens? What will be your accumulator value? Accumulator value will be given immediately in the instruction itself, right? So whatever is there in this operand field, that will become your, this is the value that will be loaded into the accumulator directly. So in this case, the accumulator will be 2000. So if accumulator is 2000, B can't be the answer, D can't be the answer because it's an MCQ. Let's eliminate quickly. Okay, this will make our life simpler. You can also do it faster. Direct addressing, right? Again, you don't have to do it because in the remaining options A and C, the answer is 2400. But just solve it. Let's just solve it, right? Direct addressing basically means the accumulator will have whatever is stored in the memory value at 2000. This is direct addressing. You're giving the address literally, right? Whatever is stored in this address will be loaded into the accumulator. So what is loaded here? 2400, because in the address 2000 there is data 2400. So that will be loaded here. So okay, so you can't eliminate between A and C. Now if you see A and C, the third one is also the same, indirect addressing mode, right? But let's just solve it. If you're solving in an examination, because these two are same, you will not bother about it. You'll directly go to the indexed mode and answer the question much faster. But just for the sake of clarity, so what's happening in the indirect addressing mode? So you have 2000. So the accumulator, first what will happen is whatever, because it's indirect addressing, right? So whatever is stored in the memory value at 2000, which is 2400, because it's indirect addressing, at 2400, whatever is stored, right? So the memory of this, which is equal to memory of 2400, because 2400 is stored in the memory address 2000. So you go to this 2400, within 2400, within the memory location 2400, 2300 is stored, because it is not direct addressing, it's indirect addressing, right? That's why 2300 is there. The final thing that we have is the indexed mode. In the indexed mode, what do? We use the index register itself, right? So what will be the accumulator contain? The accumulator will say the memory address of whatever is there in the index register, which is 400 plus this 2000, right? So 2400. So what is there in memory address 2400? It is 2300. In 2400 memory address, there is data 2300. So C is the right answer here. As simple as that. Very simple question. Again, you don't have to solve for all the 4 addressing modes. If you just solve for immediate and indexed, you can eliminate options and answer that C is the right one. Fairly straightforward and simple question again. Cool. Okay, so this is a slightly lengthy question. So please read it carefully, don't panic. Again, even in computer organization, there are simple questions, right? So don't panic. In every subject almost, you will always have easy questions that you can score from. And simple design of instruction sets and addressing modes is one of the easiest topics in computer organization. You will get something like this easily. Again, draw diagrams. Please don't miss that. Let me write it down here. Please draw diagrams. Don't worry about the length of the question. This most likely may just be a 1-mark question. Again, please read the question carefully. It's an NAT. Again, please fill in what is being asked in the fill in the blank. Again, please limit the general questions here, because I will not be able to answer them while others are solving the questions. I will answer them at the end of the session for sure. Very simple question. There is so much of drama that's happening in the lengthy part of the question, but it's actually a simple one. Cool. I think most of you got it right. So let's go through the question, right? As we go through, let's fill in all the details. So again, it says some ARM V8. We don't have to worry about all that. It says 24 bits are used for the instruction, right? So we have 24 bits, right? Let's break this 24 bits. That's what we have to do. Every arithmetic instruction with immediate value, every arithmetic instruction with immediate value has 4 parts. Okay, I think this is mistakenly typed here. Has 4 parts as shown follows. An opcode, right? So you have an opcode as usual, right? The name of the destination register. So destination register, I'll just call it DR, okay, just for short. The name of the source register, SR, holds the, okay, and the immediate literal value expressed in 2 complements binary representation. So there is an also immediate value that's here. Okay, so there is an example that's also given here. Cool. The instruction set for the computer consists of 30 different instructions, which means the number of bits for opcode will be 5. Because 4 can only represent 16, 5 can represent 32, and we have 30 here. That's good. Next, the range of immediate values is from minus 1024 to plus 1023. If you look at this, whether it's in 2's complement format or any format, right? How many values are there in this range? From 1024, from minus 1024 to plus 1023. If you count the 0 also, which is here, right? See, look at the number of values that you need to represent here, right? So the number of, forget about, again, we don't have to worry too much about the 2's complement representation here, because if you want to represent, let's say 0 to 1023, let's say you want to represent 0 to 1023, right? You need 10 bits, right? You need 10 bits here because 2 power 10 is 1024 and there are 1024 values that you need to represent here. This is exactly double of that range, right? This is exactly double of that range. So whether you're using 2's complement or whatever representation you're using, you need one more bit, right? So you need 2 power 11. So there are 2 power 11 values that you need to represent. So you need 11 bits there. So 11 bits go for a toss here, right? So 24, 16 bits are gone. So you're left with 8 more bits. So 4 bits for the destination register, 4 bits for the destination register, 4 bits is the maximum that you have for the source register. Now what is the question asking? The question is saying, assume that the same number of bits are used for destination and source registers, good. What is the maximum number of general purpose register that a processor can have, right? Again, because there are 4 bits for destination and source, you can have a maximum of 16 general purpose registers, 2 power 4, done, right? Very simple question, very straightforward. Again, that's why I said it's a 1 mark question, right? Very straightforward one. Again, this topic is the easier one. As we keep going forward, we'll encounter more interesting ones. Okay, again, a very simple question here. This is also a 1 mark question. Again, when we solve slightly more harder topics in COA, we will surely encounter harder problems, trickier problems, especially with pipelining and things like that. I sometimes get confused between the topics in operating systems and COA because they're so close to each other. Again, this is more like an aptitude question, to be honest with you. You just have to know the terminology and what it means, and then it's a simple aptitude question. Again, please pick an answer. There is no point writing an expression. This is very easy. As those of you who have solved it will quickly recognize that this is just an aptitude question. Again, the question says, what is the answer approximately? It doesn't say round it to 2 digits or anything. So pick whatever is closest to your answer. Approximately. That's why the keyword approximately is used here. Okay, so let's solve this, right? So you have 2 CPUs as mentioned in the question. The first CPU takes a program, right? And the instruction count is 50,000 instructions. So you have 50 into 10 power 3 instructions with average cycles per instruction as 2.2, right? So this is the total number of cycles that it would need to execute this program, which has 50,000 instructions. And the CPU clock speed is 0.9 gigahertz. So which means one cycle is completed in 1 by 1.9 gigahertz. So giga basically is 10 power 9, right? So again, this is 1 by, I'm just multiplying this. So this is number of instructions, right? This is, this is the number of instructions. This is the number of cycles per instruction into 1 by this is the time taken per instruction, right? So this will roughly, approximately, this will be equal to 5.789 into 10 power minus 5 seconds, right? If you just solve this using a calculator. Then you have CPU 2. Right? What does the CPU do? Because they're using a better compiler and things like that, they have only 40,000 instructions. So 40 into 10 power 3, and each instruction takes 3 cycles now, right? More cycles, right? Probably because of the architecture and things like that. So more cycles, but this CPU has a higher clock rate, which means its frequency is higher, which means each cycle can run in 1 by 2 power 5 into 10 power 9, right? And this is approximately, if you just simplify this, you get it as 4.96 into 10 power minus 5 seconds. And it's talking about the speed up, right? So speed up is this by this. If you solve it, you'll get 1.167 if I'm not wrong. So of course, if you round it to 2 decimal places, it should be 1.17. But the question says which of them is approximately the value. The closest value is B. Again, simple aptitude problem, right? Again, this topic, specifically this topic in computer organization is one of the easiest, and hence also very, very scoring for you, right? Again, we'll encounter more challenging ones a little later for sure. So let me now tackle some of the questions in the chat window. I saw a question that one of the students posted while this was happening. So Ayub says, due to my work hours, I'm not able to attend the live sessions. Where can I find them? Again, all the live sessions, if you're a course enrolled student, they're in the respective sections of the course videos themselves. Again, all the public live sessions are available on YouTube. You can just go to our channel and you can see all of them. So the whole list of live sessions that have been conducted for this year in the first iteration, everything is there in the corresponding section. So for example, this will be there in COA itself. If you're not able to find anything, always email us and we'll help you with that. There is one very nice question that a student asked, which was, my college doesn't have good placements. Should I only focus on GATE prep? Again, a lot of students, a vast majority of students, close to 99% of students who prepare for GATE, primarily prepare for GATE to get into a master's program so that their chances of getting into top companies improve. That's the reality of it. A very small percentage go for a master's program in India for research. That's a fact. Whether that's good or bad is secondary, but that's a fact. Now, having said that, if your college does not have any placements, that's a different story. But if your college has some placements, please sit in those placements. Even if you have some off-campus placements, please sit in those placements so that you have the placement as a backup option in case you don't get a good rank or a good university that you would like to within GATE itself. So always have backup plans. Don't just say, hey, I will only prepare for GATE and nothing else. That may not be the optimal strategy. Try and make sure that you have backup plans in case you don't get a good rank, or you could not perform your best, or there was a hard set that you got. 100 things can go wrong in the last minute. Unfortunately, GATE examination is once a year. So it's better to have backup plans, which is a job. Okay, cool. So this is Brajendan. Are there enough opportunities in PSUs after GATE CS? No, there are very, very few opportunities for PSUs, and that's the reality of it. Because most PSUs are typically large industries like steel plants, like oil refineries, like power corporation, some of these organizations, right? They don't need as much computer science folks as they need, let's say, electrical engineers or mechanical engineers, etc. So that's the reason why CS folks themselves don't have as many options, but there is certainly DRDO and ISRO, if you're interested in those organizations, and institutes like Baba Atomic Research Center, which have their own examinations. Very similar to GATE, maybe a few topics additional here and there. Some of them also have slightly subjective type of rounds. But in general, the syllabus is very similar to GATE. So those institutions conduct their own examinations. Like ISRO has its own exam. If I'm not wrong, DRDO has its own exam. Baba Atomic Research Center. They all hire CS folks, but through their examinations and not through GATE. Cool. So Piyush says, I'm done with all concepts of GATE. Can I start problem solving now? No, it's good. I mean, I wish you solved problems while learning the concepts itself. And I'm hoping you've solved at least some problems, if not all the problems. But problem solving is an equal component of learning for GATE. Roughly speaking, you should spend 50% of your time on learning concepts, 50% on problem solving, roughly speaking, right? Of course, if you already know the concepts, you can skip them, go directly to problem solving. Or if you're a phenomenal problem solver, you can skip some of the problem solving, obviously. But in general, 50-50 is a good balance that we recommend. Cool. So very nice question. GRE versus GATE. Very nice question. This is something that I had in mind when I was an undergraduate student myself, which was should I attempt GRE, go to a foreign university, or should I get into GATE? There are a couple of things that you can consider here. This is from my own experiences. One, if you're studying in a small engineering college, getting into the top universities in the US is hard. Because the competition for top universities like Stanford, Berkeley, MIT, CMU, etc. is very, very high. And you need, again, because I've had a lot of top university undergraduate students working in my teams earlier. Most of them could not get admits at Stanford and Berkeley's because it's super competitive. The students from the world's best universities, the gold medalists from the top universities, like with stellar track record, get into these master's programs. So I had a choice which I said, okay, if I cannot get into the top universities of the US, what is my next best option? Should I spend some 20-30 lakhs, get into the next tier of universities, or is Indian Institute of Science or IIT Bombay better? When I did the math around expenses, I felt that because I could crack GATE, I thought I could do reasonably well in GRE also. So I thought, okay, if I have both of them, why should I spend 20-30 lakhs and have a student loan at the end? While the government of India, they used to give us a stipend of 8,000 rupees then. They're giving me a stipend, I'm getting access to world-class education. Anyway, I'm going to learn. At the end of the day, you as a student matters more than the institute with so many publicly available resources. Like there is a phenomenal library at Indian Institute of Science, which I never entered because I didn't need to. Everything I needed was available with an internet access, which I had in our labs and in our accommodation, right? So at the end of the day, when you get in, like it's a choice like that, right? If you cannot get GATE, right, and if you're sure that you want to, suppose if you got into top 100 universities through your GRE, that's a good option, right? Again, there is money that is at play. There is also whether you can get into these institutions is a second thing. So these are some of the trade-offs that I had to think of. And I decided to go into an Indian Institute of Science or an IIT Bombay because I was getting great access to some of the best researchers in India. And literally they're paying me back. I don't have to pay. I have zero student loan. So these were some of the things that I thought of when I was a student. Cool. So somebody says, can I get into MIT for AI after IISc? Yes. So I have batchmates of mine who, after finishing their IISc masters, who have worked on a lot of research work at IISc, worked for a year or so after their MTech, published a lot of research, and they've gone on to do for PhD at MIT, some of them at Stanford, Berkeley, all the top universities. Again, you have to be a topper at IISc, have a very strong track record to get into MIT for a PhD program or Stanford for PhD program, because the PhD programs at these universities are hyper competitive, super duper competitive. So you have to be a top student at your respective university. Okay, nice question. So this is Krishna, who says, how to deal with COA? Again, what is the aspect that troubles you with COA? That's what I never understood, right? Because if you think of COA, right, it feels like, if you know DLD, right, COA feels like a very natural extension to it, right? At least I never felt COA to be on the harder side. There might be a couple of topics that are a little tricky, but in general for COA, at least my approach to it is draw diagrams. Try to visualize what's happening, because I can't go into a CPU and see it. I try and draw tons and tons of diagrams. You can see it even on our YouTube videos or on our course videos. We try to draw a lot of diagrams because that's the way we learned ourselves. That's the way at least I surely learned COA. So if you can break everything down into these block diagrams, it will help you understand what's happening, and it's actually easy. Of course, there are a couple of topics that will be hard, like any other subject. But don't panic with COA. Don't have that fear that it's too hard or anything like that. Diagrams, try to understand these block diagrams of architectures, instructions, all these things logically, and it feel very natural to you. So Pankaj, who says, how to tackle surprising questions in GATE? Very nice question actually. So if there is some very outlier question, right, very out of the norm question, remember it is out of the norm for everyone, not just you. If you understand the question, if you think you have a fair shot at it, tackle it, right? If you think you can solve it even with 50-60% probability, go ahead, solve it. If you're completely lost, ignore it. Go back to that question the next time, like even when you're solving the question paper, right? A lot of students do this, which is they go through one iteration of the question paper, solve all the questions that they can easily solve, mark those questions that they think they might be able to solve if they put in a little more effort. And there'll be some questions which they simply can't solve. So you might want to tackle these surprise questions or slightly out of the norm, outlier questions in the second iteration. Sometimes you can just skip it. Remember, that's okay, right? Instead of losing marks, or again, if it has negative marks, instead of losing marks, you might as well just leave it. Okay, so Manik says, if the syllabus is not complete, is it wise to practice test series using an open book approach? This is a tricky one, Manik. There is a little risk in doing this. The reason I'm saying this is, if you're used to solving in an open book format, in the examination, you don't have a book in front of you. So you're not simulating the same problem solving environment as you would encounter in the exam. That might hinder you in the examination, because you might get used to a situation where you're trying to look at your notes or look at your book for some formula or for some diagram, right? So I wouldn't recommend it. Unfortunately, GATE is not an open book exam. Again, if GATE were an open book exam, it would be like exponentially harder by design, right? I've gone through some open book examinations in Institute of Science. Those exams are the hardest, because the answers or the solutions or the directions, you won't find it in any notebook of yours, right? You have to think from scratch and solve it. So to put it bluntly, I wouldn't recommend it, but if you don't have any other option, that might be okay. So Avnish says, how to score max in math and aptitude? Again, aptitude, if you're not very comfortable in English, probably you might want to just do your best and leave the rest, because learning all of English just for GATE might be too time taking. But as far as math and aptitude are concerned, this has been my strategy, which is, for any problem in math and aptitude, at least I try to derive it from first principles. Even in aptitude, right? Draw diagrams, try to derive everything from first principles instead of being formulaic. Again, even not naive Bayes, sorry, even Bayes theorem, right? Again, naive Bayes is a machine learning technique which is based on Bayes theorem. But if you look at Bayes theorem in probability, right, it's so simple that you can actually derive it in 10 seconds. In the examination, you can derive it. You don't have to remember it. So a lot of math, of course, there will be some exceptions. So like, for example, there will be some properties in group theory that it's good to remember these properties, or similarly, there will be some properties of graphs. It's good to remember these properties of various types of graphs because you can't prove that on the fly in the examination. But a lot of other things related to permutations, combinations, even a lot of graph theory, you can arrive at the problems from first principles. So math, especially math, know the key properties, try and learn to derive things from first principles. Aptitude is much, much simpler. You can derive everything from first principles. Like draw diagrams, try to solve it from scratch. It will not take a lot of time. With a little bit of practice, you'll get very good at it. Cool. One second. So CN syllabus for GATE is huge. That's true, Pankaj. Again, some topics have been removed last year, thankfully, but also some new topics have been added for CN. So CN is slightly on the lengthier side because there are so many facts also that you have to remember. That's the unfortunate reality of the subject, and GATE also asks questions about packet formats and things like that. The only strategy that I have seen work for CN, especially for me or for some of our mentors, is they revise the notes much more aggressively because the subject is slightly lengthier. Cool. So somebody is asking, are internships really important? Again, for what? For GATE, they're useless. For admissions to top US universities, if you're doing an internship, it certainly adds value. It's not that it's bad, but again, the better the company you're doing an internship, the better value it is. So Bhargav has a nice question. What about the TAFR, Tata Institute of Fundamental Research? So TAFR only admits for PhD programs, not for master's programs. But there is a small clause there. If you finish all the coursework required for a PhD program, and if you want, I've seen a few people exit the PhD program because it's fairly dense and hard. So I think if you exit after 2 years after completing all the coursework, they will give you a master's degree and let you go. But there is no admission to a master's program. There are only admissions to PhD programs. And TFR is a terrific research center, lot of fundamental sciences, mathematics, etc. I mean, it's comparable to any other top research institute in India and probably comparable to the top research institutes in the world. The problem with CS at TAFR is there are very few faculty working in few areas. So if you find a faculty who is working in an area that you are very passionate about, great. Because it's a small university, small number of students, very research focused, much more than an Institute of Science, because there is no master's degree. You have to get a PhD, right? But if you go into TAFR and assume that there will be some faculty for some topic that you are interested, but there is no faculty, then that's game over for you. This is a risk with any small university or any small research-centric university, that you have to first find the appropriate professor for you, and then, or appropriate area, and make sure that there is at least one professor working in that area, then everything will be great. Okay, this is Sinogia who says, which is good, 2 years experience in a company or placements after MTech from IIT? Very nice question. It all depends on your work experience. Again, this is something that we often tell students that, look at this, let's look at the playing field, right, for a fresher. I'll give you the example from a top product-based company. So, or even a product-based startup. Suppose you have a BTech and you join a top product-based company or a good product-based startup. Good product-based startup, which is like, let's say your compensation is in the 15 lakhs plus, around that range. Of course, top product-based companies give you about 18-ish. This is gross, not CTC. So when you join these organizations, in 2 years, you go from an SDE 1 or a software development engineer 1. In 2 to 2.5 years, you can become a software development engineer 2. Your compensation roughly doubles by then. The same, so if you got into a good product-based startup or a good product-based company, and if job is the only priority, then there is no point joining an IIT or IISc for that matter. Let's be realistic, because the same 2 years, if you spend at IISc or IIT, And if you graduate, if you join Amazon or even a good top product-based startup or something like that, right? Your compensation is just going to be some 50,000 more than a BTech student. You're still going to be an SDE1, right? Your compensation probably will be 18.5 lakhs. And you will still take 2 years to become SDU2. So the guy who did not join the MTech program, but who got into a top product-based startup or a top product-based company, by the time you join as SDE1, if he works similarly hard, he'll become SDE2, right? He's already one level above you, right? So if you're getting into, if job is the only thing, if you do not care about research careers or if you don't care about research and further education, if job is the only priority, then if you got into a good product-based startup or a good product-based company, for a fresher, if the compensation is around 14 plus, there is no point joining. An IIT. And we have some students like that. We have some students of our own who got in the top 10 ranks last year, who did not join because they got offers comparable to an SDE1 at a top product-based company. Right? We have students like that, by the way. Right? So if that's the case, don't worry about it. Right? But at the same time, if you're like, no, I want to spend 2 years, learn an advanced topic, become an expert in a sub area like machine learning or distributed computing, then a master's degree is very helpful. Okay, so Ankur says, I'm currently left with math and algorithms. What should be my strategy for the next 4 months? My suggestion is first please finish math, because there is so much weightage to math, right? First finish that. Because you've completed some programming, data structures, etc., then you can complete algorithms. There will be some overlap of concepts like graph theoretical algorithms and graph theory in math. So my suggestion is probably you should spend the next 1 month finishing math, maybe a few weeks after that finishing algorithms, and then get into the second iteration of revision. Again, nice question from Elias, who says, how to stay stuck as exams comes nearer? Again, as I've often mentioned, as many of our mentors also often mentioned to you, instead of thinking about motivation, think about discipline. Block time in your day and dedicate that time just for gate preparation. That is the only way you will be disciplined, you will complete everything. Don't look for external motivations. It is discipline that is much better. And avoid social media as much as you can. Focus on your learning, because social media is the biggest distractor for all of us, not just you, even for me. And I try to avoid it as much as I can, right? So if you can avoid it, that might be better. And try to dedicate something like 4 to 5 hours, given that we have roughly about 4 months, maybe 4 months and a week before the examination. It's better you focus on it, go full throttle, go full energy. Whatever extra time you have left in the day, just make sure that you're working towards GATE. That's a better strategy. So Kallol says, there are all India mock tests on 24th of October. How many marks am I good level? Okay, so how many, I think the question here is how many marks should we be getting? The higher the better, obviously. Again, I'll have to look at the question paper on 24th because I'm a little confused which question paper is there on what day. But we'll give you sort of like a relative ranking, right? We will inform you where you stand. But if the question paper is not very hard but normal level hardness, I think you should try and get 70 plus if you want to be in the top 100-ish or top 200-ish ranks, right? That's a good benchmark. Of course, everybody need not be in top 100 or top 200. Even if you're in the top 300 or top 500, I think things will be pretty good for you. Okay, folks, I'll wrap up today's session with that. Thank you very much. Again, see you, all the course enrolled students, see you on the Friday for the second live session. All the folks on YouTube, see you on the coming Tuesday again.